somewhere beneath the surface of Mexico's Pacific waters, in the stretch of ocean where the Baja California peninsula reaches down toward the tropics. An entire generation of divers grew up hearing about a spectacle that seemed almost too extraordinary to be real. Hundreds of scalloped hammerhead sharks moving together. In a single dense, swirling formation, circling seamounts in numbers large enough to blot out the sunlight filtering down from the surface above. Divers who witnessed it in the decades when these schools were still reliably abundant often described the experience in strikingly similar terms, dropping into open water above a submerged pinnacle, current tugging steadily at their fins, and slowly becoming aware of a shifting gray wall materializing out of the blue haze at the very edge of visibility, dozens and then hundreds of individual sharks resolving into a single vast living shape, banking and turning in unison with a coordination that seemed to belong more to a flock of birds than to a group of solitary ocean predators. For decades, these schools ranked among the most sought-after sights in all of underwater filmmaking, a bucket list encounter for divers and documentary crews alike. And for just as long, that same spectacle has been quietly disappearing, the schools growing thinner and more elusive with each passing year until a sighting that once might have been considered reliably repeatable became, for an entire generation of underwater cinematographers, something closer to a rumor. A story passed down from an older generation of divers about a version of these waters that no longer quite exists. This is the story of the hammerhead. Shark, one of the ocean's strangest and most instantly recognizable predators, and of the surprising, complicated relationship between human ambition, human appetite, and the fate of an animal that has patrolled the world's oceans for tens of millions of years. To understand why hammerhead sharks have become so difficult to find, it helps first to understand exactly what makes them so unusual in the first place. The hammerhead's defining feature, the wide, flattened extension of its skull known as the cephalofoil, is not simply a strange evolutionary flourish. It is a highly specialized sensory instrument densely packed with electroreceptor organs capable of detecting the faint electrical fields generated by the muscle contractions of hidden prey. Spread that sensory array across a wider surface area than almost any other predator in the ocean possesses, and a hammerhead effectively gains a built-in metal detector for living creatures, allowing it to sweep the sandy sea floor and locate prey buried entirely out of sight, an ability particularly well suited to hunting one of its favorite meals, stingrays hidden beneath a thin layer of sediment. Researchers who have studied this hunting technique closely describe hammerheads using their oddly shaped heads almost like a metal detector wand, sweeping side to side in slow, methodical arcs across open sand flats until the telltale electrical signature of a buried ray registers strongly enough to pinpoint an exact strike location, at which point the shark will pin the ray to the seafloor using the flattened underside of its cephalofoil before maneuvering to deliver a disabling bite, frequently targeting the ray's pectoral fins first in an apparent effort to limit its prey's ability to escape. The wide-set placement of the hammerhead's eyes, one positioned at each end of that distinctive skull, also grants the animal an unusually broad field of binocular vision, allowing it to judge distance and depth with a precision most other shark species simply cannot match. And recent research using specialized underwater cameras has even suggested that hammerheads may possess close to 360 degrees of vertical visual coverage, allowing them to see both directly above and directly below their own bodies simultaneously, an advantage no other shark species is currently known to share. Far from being an evolutionary oddity, the hammerhead's strange silhouette represents one of the more elegant pieces of predatory engineering found anywhere in the natural world, refined over tens of millions of years into a shape that, if anything, looks even stranger. The more closely scientists come to understand exactly how well it works. There are more than 9 recognized species of hammerhead shark found in oceans around the world, ranging from the diminutive bonnethead, rarely growing much beyond 3 feet in length, to the great hammerhead, a genuinely massive predator capable of reaching lengths approaching 20 feet. The bonnethead holds its own distinction among sharks worldwide as one of the only species ever documented supplementing its diet with significant amounts of plant material, regularly consuming seagrass and coastal habitats, and, according to research examining its digestive processes, actually deriving genuine nutritional value from that plant matter rather than simply ingesting it incidentally while hunting crabs and other small invertebrates hidden within seagrass beds, a discovery that surprised marine biologists who had long assumed sharks to be exclusively obligate carnivores. It is the scalloped hammerhead, distinguished by the gentle scalloped notches running along the front edge of its cephalofoil, that has become most closely associated with the extraordinary schooling behavior that made places like the seamounts off Mexico's Pacific coast so famous among divers in the first place. unlike the vast majority of shark species, which tend toward solitary lives, punctuated only occasionally by loose, temporary aggregations, scalloped hammerheads gather during daylight hours in structured, hierarchical schools that can number in the hundreds of individual animals, circling in a slow, almost hypnotic formation above rocky reefs and underwater peaks, before dispersing at nightfall to hunt alone in the open water beyond. Marine biologists studying this behavior have proposed a range of explanations, from safety in numbers as protection against larger predators, to socially organized mate selection, to the schools serving as a kind of communal cleaning station where the sharks can be serviced by smaller reef fish that pick parasites from their skin. Researchers tracking individual animals within these schools have also documented a surprisingly rigid social hierarchy at work, with larger, presumably more dominant females typically occupying the center of the formation, while smaller or subordinate individuals are pushed toward the outer edges, and specific postural signals, including a distinctive corkscrew-like swimming motion, appear to function as a form of social communication used to negotiate an individual shark's position within the group. But even after decades of dedicated research, much about exactly why these animals organize themselves in such a distinctive, deliberate way remains only partially understood, one of the many genuine mysteries that continues to draw scientists back to these waters year after year, hoping each season that the schools they are able to locate will be large enough and stable enough to finally answer some of the questions that have persisted since researchers first began seriously studying the behavior back in the 1970s. That mystery is precisely what has made the steep, sustained decline in hammerhead numbers across so much of their range feel like such a significant loss, not only for the ocean itself, but for our own still developing understanding of one of its most singular inhabitants. Population assessments conducted by international conservation bodies have concluded that scalloped hammerhead numbers have fallen by well over half. Across large portions of their global range over the past several decades, a decline severe enough that the species has been formally classified as critically endangered, one step short of extinction in the wild, by the international body responsible for assessing conservation status worldwide. The great hammerhead, despite its imposing size, has fared no better, carrying the same critically endangered designation as its smaller, more social relative. For a group of animals that has successfully navigated the planet's oceans since long before the first dinosaurs walked the Earth, surviving multiple mass extinction events along the way, the speed of this modern decline, unfolding within the span of a single human lifetime, stands as a particularly stark illustration of just how much pressure industrial-scale fishing has placed on the ocean's most vulnerable predators. The primary driver behind that decline is not, as popular imagination might assume, any direct malice toward the species itself, but rather a straightforward and brutally efficient economic calculation. The hammerhead's large, distinctively shaped dorsal fin commands an especially high price in the international shark fin trade, a market driven largely by demand for shark fin soup, a dish considered a luxury delicacy across parts of Asia and traditionally served at weddings, banquets, and other significant celebratory occasions. That premium price has made hammerheads a particularly attractive target for fishing operations working the waters off Mexico's Pacific coast and throughout the broader tropical eastern Pacific, where the sharks' predictable schooling behavior around known seamounts has made them, tragically, far easier for fishing vessels to locate and catch than solitary, wide-ranging species might otherwise be. The very same schooling behavior that makes hammerheads such an extraordinary sight for divers and filmmakers, in other words, has also made them unusually easy to locate and catch in bulk, turning what might otherwise function as an effective predator avoidance strategy into a significant liability once industrial fishing vessels equipped with sonar and decades of accumulated local knowledge entered the picture. But finning, however visually shocking the practice appears when filmed and shown to a general audience, in fact, accounts for only a portion of the total mortality hammerheads face each year. Marine biologists studying the broader picture consistently point to a less visually dramatic, but ultimately more consequential threat: ordinary commercial fishing operations targeting entirely different species whose lines and nets nonetheless snag hammerheads as unintended bycatch in overwhelming numbers. A shark caught this way may never have been the target of the fishing operation at all, yet it dies just the same, tangled in a gill net set for tuna or snagged on a long line baited for swordfish, one among what researchers estimate to be tens of millions of sharks lost to bycatch across the world's oceans every single year. Hammerheads appear to be especially vulnerable to this particular threat, in part because of a physiological quirk that sets them apart from many other shark species. When hooked or entangled, hammerheads tend to experience unusually severe physiological stress responses, and studies examining catch and release mortality rates have found that a very significant proportion of hammerheads die from this stress alone, even when a fisherman makes a genuine effort to release the animal alive. meaning that even well-intentioned catch and release practices, effective for many other shark species, often fail to meaningfully protect hammerheads from the ultimate consequences of being caught at all. There is, fortunately, a genuinely hopeful countercurrent running through this otherwise sobering story, and it is one that has drawn marine scientists, conservationists, and wildlife filmmakers back to Mexico's Pacific waters in recent years with a renewed sense of purpose. Beginning in the final years of the 20th century, Mexico established a series of marine-protected areas specifically encompassing some of the seamounts and offshore island groups most closely associated with hammerhead schooling behavior, placing meaningful legal restrictions on commercial fishing activity within clearly defined boundaries. Where these protections have been genuinely enforced, rather than existing only on paper, researchers have documented real, measurable recoveries in local shark populations, with schooling aggregations returning to a scale and consistency that had not been reliably observed in the surrounding unprotected waters for years. These successes have offered marine biologists something rarer and more valuable than simple hope, hard evidence gathered through years of patient underwater survey work, that hammerhead populations retain a genuine capacity to rebound when given the chance, provided that the protections extended to them are substantial enough and enforced consistently enough to actually outweigh the powerful economic incentives working against the species elsewhere. The challenge, as marine scientists studying the species are quick to point out, is that protecting a single seamount or a single stretch of coastline, however successfully, only ever addresses part of the problem for an animal that does not recognize any of the invisible lines humans draw across a map of the ocean. Scalloped hammerheads are highly migratory, and satellite tagging. Studies have shown that individual sharks regularly travel enormous distances between protected feeding and schooling grounds, passing through long stretches of open, entirely unprotected water along the way. Water where commercial fishing fleets operate with far fewer restrictions. A shark that spends its days circling safely within the boundaries of a well-enforced marine reserve may, during its nightly hunting excursions or its longer seasonal migrations, swim directly into the path of a long line or a gill net set just beyond that reserve's boundary. This has led a growing number of researchers, conservation organizations, and, increasingly, wildlife filmmakers working to document the species to argue for a fundamental shift in strategy. Expanding protection beyond isolated island sanctuaries toward entire migratory corridors, the invisible highways connecting one seamount to the next, in recognition of the fact that a species this mobile can only ever be as safe as the very least protected stretch of its entire range. Documenting all of this, the schooling behavior, the decline, the fishing pressure, and the fragile signs of recovery, has become its own significant undertaking, requiring underwater cinematography carried out at genuine depth, often in open water far from shore, working around animals that have become considerably warier of human presence than they were a generation ago, precisely because of the sustained fishing pressure they have experienced. Wildlife filmmakers working in these waters today spend weeks at a time simply waiting for a school to appear, tracking currents, water temperature, and the movements of local fishing fleets in an effort to be in the right place at exactly the right moment. A search that can just as easily end in disappointment as in the extraordinary footage that eventually makes it to a television screen. It is precisely this uncertainty, the fact that even a well-planned, well-funded expedition working with the best available local knowledge can still come up empty-handed, that makes documenting these animals today feel less like straightforward nature photography and more like a genuine investigation into what has actually happened to a population that was, within living memory, considered one of the ocean's most reliably spectacular sights. It isn't exactly this kind of uncertain, patient searching that some of the ocean's most memorable surprises tend to happen, because an ocean this rich in life rarely stays still for long, even when the specific animal a film crew has traveled thousands of miles to find remains stubbornly out of sight. The same nutrient-rich waters that historically supported such dense hammerhead populations also support an extraordinary abundance of other marine life, a food web built on the small schooling fish, squid, and krill that thrive wherever cold, nutrient-laden currents rise up from the deep ocean floor toward the sunlit surface waters above. That upwelling, driven by the interaction between deep ocean currents and the underwater topography of seamounts and coastal shelves, creates some of the most productive marine habitats found anywhere in the world's oceans, and it draws an entire cast of large marine predators into the same general waters where hammerheads have historically gathered, whales, dolphins, and other shark species all converging on the same seasonal abundance of prey. Among the most memorable of these unplanned encounters involves one of the ocean's most surprisingly elusive whale species, the bride's whale, a baleen whale that, unlike many of its more famous relatives, tends to remain in warm tropical and subtropical waters year-round, rather than undertaking the long seasonal migrations that carry species like the humpback and the gray, whale between polar feeding grounds and tropical breeding waters. Bride's whales are lunge feeders, employing a hunting technique in which the animal accelerates rapidly through a dense concentration of small schooling fish, mouth agape, engulfing an enormous volume of water and prey in a single explosive motion before straining the seawater back out through the comb-like baleen plates lining its upper jaw and swallowing whatever fish remain trapped behind. Witnessing this behavior firsthand, a multi-ton animal erupting through the surface of the water in pursuit of a school of fish ranks among the more genuinely startling encounters available anywhere in the natural world, precisely because Bride's whales spend the overwhelming majority of their time feeding at depth, well out of sight, only occasionally surfacing to lunge feed in a way that offers observers on a boat or in the water any real glimpse of the behavior at all. The broader story of whale recovery across the world's oceans provides its own instructive parallel to the more troubled story of the hammerhead shark, offering a genuinely hopeful counterexample of what sustained legal protection can accomplish when given enough time to work. Commercial whaling operations, conducted with increasingly industrial efficiency throughout the 19th and 20th centuries, drove numerous whale species to a small fraction of their historic populations, in some cases reducing entire regional populations by well over 90% within the span of only a few decades. The establishment of international protections beginning in the middle of the 20th century, culminating in a global moratorium on commercial whaling that took effect in the 1980s, halted that decline and allowed a genuine, if slow and uneven, recovery to begin. Fin whales, the second largest animal alive today after only the blue whale, were hunted with particular intensity throughout the 20th century. Their populations in some regions reduced to levels so low that biologists feared genuine permanent ecological collapse, with some historical whaling records suggesting that certain regional populations were reduced to only a few percent of their original numbers by the time industrial whaling activity finally ceased in the areas where they had once been most heavily targeted. Yet in recent years, researchers working in some of the very same waters once devastated by industrial whaling, including remote stretches of the Southern Ocean near the Antarctic Peninsula, have documented extraordinary gatherings of fin whales numbering in the hundreds of individual animals, feeding together on dense concentrations of krill in a spectacle that had not been reliably observed at anything close to that scale for the better part of a century. Researchers involved in surveying these gatherings have had to contend with brutal operating conditions to capture and verify the sightings, spending weeks at a time in small vessels, navigating waters known for sudden, severe weather changes, with only a small handful of days across an entire expedition offering conditions calm enough to safely conduct aerial survey work or launch camera equipment capable of documenting the full scale of what researchers were witnessing. The persistence required to document a recovery of this scale mirrors, in many ways, the same patient, weather-dependent, often frustrating field work required to document hammerhead schools in the waters off Mexico, a reminder that some of the ocean's most significant stories, whether tales of recovery or decline, only reveal themselves to researchers and filmmakers willing to spend weeks waiting for a handful of good days. Encounters like these offer a genuinely striking illustration of a broader ecological principle that researchers studying both whales and hammerhead sharks return to again and again. Given sufficient time and sufficiently robust legal protection, marine populations that have been pushed to the very edge of collapse retain a real demonstrated capacity to recover on a scale that can still surprise even the scientists who have spent entire careers studying them. It is a principle that carries particular weight for anyone hoping that the hammerhead's current trajectory might eventually be reversed, since it demonstrates, in concrete and well-documented terms, that even a species reduced to a small fraction of its historic population by direct, sustained human exploitation is not necessarily beyond the point of meaningful recovery, provided the underlying pressure driving that decline can actually be lifted for long enough. That capacity for recovery does not, however, make the underlying math any less unforgiving for a species like the hammerhead, whose biology leaves considerably less room for error than many people assume. Sharks in general reproduce far more slowly than most fish species, reaching sexual maturity only after many years of growth and typically producing relatively small numbers of offspring compared to the enormous broods laid by many bony fish. Scalloped hammerheads, specifically, may not reach reproductive maturity until they are well over a decade old, and females give birth to relatively modest litters after lengthy gestation periods, a reproductive strategy that works perfectly well under natural conditions, but that leaves the species with almost no capacity to absorb the kind of sustained heavy fishing pressure that a faster reproducing species might be able to withstand. This slow reproductive rate is precisely why population collapses among sharks, once they begin in earnest, tend to unfold over a genuinely alarming timescale, and why recovery, even under the best possible legal protections, inevitably takes considerably longer than conservationists or coastal communities dependent on healthy shark tourism might prefer. That tension between economic necessity and long-term conservation runs directly through the communities living along Mexico's Pacific coast, many of which depend, in one way or another, on the ocean for their livelihood. Small-scale fishing operations, often family-run and passed down across multiple generations, have historically targeted a wide range of species, including sharks, as a genuine and often economically essential source of income in coastal towns with comparatively few other reliable employment opportunities. Local fishermen interviewed by researchers and documentary crews working in the region frequently describe fishing not as a matter of casual choice, but as an inherited necessity, the primary and sometimes only realistic way of supporting a family in communities where alternative industries remain scarce. This economic reality complicates any simple narrative of villains and victims. The individual fisherman hauling a hammerhead onto his boat is rarely acting out of malice toward the species, but rather responding to genuine economic pressures that conservation policy alone cannot fully resolve, without also addressing the underlying question of how coastal communities are meant to sustain themselves once historically abundant fishing grounds have been placed off limits. It is this same tension that has increasingly pushed conservation organizations working in the region to pursue strategies built around alternative economic incentives, rather than restriction alone, recognizing that protections imposed without local buy-in tend, historically, to prove far less durable than those built in genuine partnership with the communities most directly affected. Ecotourism, built specifically around shark encounters, has emerged as one of the more promising of these alternative models, offering coastal communities a way to generate meaningful income from living, swimming hammerheads, rather than from sharks pulled dead from the water, an approach that researchers studying its economic impact in other shark tourism hotspots around the world have found can, under the right conditions, generate considerably more long-term revenue for a local community than a single catch ever could. A single hammerhead, capable of drawing paying divers to the same dive site for years on end if it survives, can in principle generate a stream of tourism income that far exceeds the one-time value of its fins sold into the commercial trade, a calculation that has proven persuasive enough in several well-studied shark diving destinations around the world to shift local economic incentives meaningfully away from fishing and toward conservation-minded tourism. Building that kind of durable community-supported tourism economy around hammerheads specifically, however, has proven considerably more difficult than doing so around species with more predictable, less migratory behavior, precisely because the schools that draw paying divers in the first place have themselves become so much less reliable to find. A dive operator promising guests a hammerhead encounter today must contend with genuine uncertainty about whether any sharks will actually appear on a given day, an uncertainty that did not exist a generation ago when schools could be found with far greater consistency, creating a difficult chicken and egg problem in which the very decline that ecotourism is meant to help reverse also undermine the reliability of the ecotourism business model itself. Conservation organizations working directly with coastal communities have responded to this challenge by emphasizing longer-term, more diversified approaches, combining shark-focused tourism with broader marine wildlife viewing opportunities, scientific research partnerships that bring outside funding and expertise directly into local communities, and educational programming aimed at younger generations growing up in fishing families, in the hope of gradually building an economic and cultural relationship with these waters that does not depend entirely on any single, increasingly unpredictable species. Whether this kind of ecotourism-driven model can scale successfully enough to meaningfully shift the underlying economics facing hammerhead populations across their full migratory range remains an open and actively studied question. But it represents one of the more concrete, actionable paths forward currently being pursued by researchers and conservationists working directly in these waters. It is also, notably, a strategy that depends heavily on exactly the kind of patient, high-quality underwater documentation that wildlife filmmakers spend months at a time working to capture. Since footage of a genuinely spectacular hammerhead school, seen by a global television and streaming audience, does far more to build public and financial support for marine-protected areas than any statistic or policy report could accomplish on its own, closing a loop between conservation science, local economic incentive, and popular wildlife filmmaking that has become an increasingly central part of how species like the hammerhead are protected in the modern era. What ultimately emerges from spending real time in these waters, whether as a scientist, a conservationist, or simply a documentary filmmaker patiently waiting for a school of sharks that may or may not appear, is a considerably more complicated and more hopeful picture than the simple story of decline that so often dominates public conversation about sharks in general. The hammerhead is not simply vanishing, it is caught in the middle of a genuine, unresolved contest between the economic pressures that have driven its decline and the growing scientific understanding, legal protection, and community-level innovation working to reverse it. The same waters that have witnessed the steady disappearance of once massive schooling, aggregations have also, in the very same recent years, witnessed real, documented recoveries within protected zones, extraordinary unplanned encounters with whale species whose own populations were themselves pulled back from the edge of catastrophe within living memory, and a growing, increasingly organized effort among scientists, filmmakers, and coastal communities alike to ensure that the next generation of divers inherits an ocean where a hammerhead school is a common sight once again, rather than an increasingly rare and treasured memory captured, with great patience and considerable luck, on film. The story of the hammerhead shark in the end is really a story about time, about how quickly a population millions of years in the making can be pushed toward collapse within the span of a single human lifetime, and about how much patience, legal commitment, and genuine partnership with the people who share the ocean with these animals it will likely take to give that same population any real chance of recovering. Every school of hammerheads that still gathers today above a protected seamount, every unexpected whale that surfaces mid-search in the middle of an entirely different expedition, stands as a small, living reminder that the ocean, for all the damage it has absorbed, has not yet given up its capacity to surprise, to recover, and to reward exactly the kind of patient, sustained attention that scientists and conservationists are only now beginning to give it in earnest. Whether that reminder arrives in time to reverse the hammerhead's current trajectory remains, for now, one of the genuinely open questions hanging over these waters, one that will likely be answered not in a single dramatic encounter, but in the accumulated results of years of protected water, careful science, and the slow, patient work of communities and scientists alike, learning to share the ocean with one of its strangest and most remarkable inhabitants.